Today we are going to deal with heat capacity and specific heat capacity of a substance. So, what is meant by heat capacity of a substance? It is defined as the amount of heat required to rise its temperature through 1 degree. The amount of heat required to rise the temperature of a given substance by 1 degree. For example, I am taking a bucket of water. How much heat I have to give to increase its temperature by 1 degree? That is called heat capacity of water. If I take oil, how much heat is required to rise the temperature of that given mass, that given volume of oil by 1 degree? So, that is called heat capacity. So, heat capacity of different substance is different. When I compare water and oil, water is having high specific heat capacity. So, the heat capacity is denoted by the letter S, and heat capacity is characterized by the quantity of the substance also. That means if more substance, more is the quantity of substance, the more heat I have to apply to rise its temperature. For example, to rise the temperature of 1 glass of water by 1 degree, I need to apply less heat. But for 1 bucket of water to 1 degree, I have to give more amount of heat. So, the heat capacity depends upon the amount of the substance. So, I will write like this: S is equal to delta Q divided by delta T. Delta Q is amount of heat supplied to the substance, and delta T is the rise in temperature. And SI unit is joule per Kelvin. SI unit of specific heat, not specific heat, SI unit of heat capacity is joule per Kelvin, delta Q by delta T. Now, what is specific heat capacity? So, heat capacity and specific heat capacity are entirely different. Specific heat capacity means how much is the heat required to rise the temperature of 1 kilogram of a substance by 1 degree. 1 kilogram. Heat capacity, I gave the definition like this: heat required to rise the temperature of a given substance by 1 degree. So, given substance means amount of substance. Amount can be small, amount can be big. But specific heat capacity is not like that. It is the heat required to rise the temperature of 1 kg of substance by 1 degree. So, the amount of substance is always stable. It is always steady. There is no change in the amount. 1 kg of substance by 1 degree. That is specific heat capacity. So, it is a unique value for a given substance. It is a unique value for a given substance. So, when I compare the specific heat of water and oil, water is having high specific heat. If I use specific heat capacity of land and sea, sea is water. So, specific heat of water is more than that of land, and that is why land gets heated up and cools down faster than water, and that is how you are getting land breeze and sea breeze. You have studied in 8th standard. So, land breeze and sea breeze occur because water is having high specific heat capacity than land. So, water heats up slowly and it cools down also slowly. So, specific heat capacity is denoted by letter C. C is equal to delta Q divided by M into delta T. Delta Q divided by M into delta T. M is called mass, delta T is the rise in temperature, and delta Q is the amount of heat applied. And SI unit is joule per kilogram per Kelvin. Heat capacity, the SI unit was joule per Kelvin, and here the SI unit is joule per kilogram per Kelvin. That's the difference between both. Now, what is molar specific heat? Molar specific heat means it is the heat capacity per mole of a substance. Heat capacity per mole. So, in specific heat capacity, I told you, heat required to rise 1 kilogram of a substance by 1 degree. Here what I am saying is heat required to rise the temperature of 1 mole of a substance by 1 degree. 1 mole, instead of 1 kilogram I am taking 1 mole. 1 mole of a substance by 1 degree. That is molar specific heat. So how can I get molar specific heat? Just take heat capacity divided by number of moles. Heat capacity divided by number of moles. So I am writing like this: molar specific heat capacity is C, written as C itself. That is S by mu, where mu is the number of moles. S is called what? Heat capacity. So heat capacity by number of moles will give you molar specific heat capacity. So delta Q by mu delta T. So just compare these two equations. Here it was C is equal to delta Q by m delta T. That means heat capacity divided by mass. But here delta Q divided by mu delta T. So heat capacity divided by number of moles. So here the SI unit will be joule per mole per Kelvin. Joule per mole per Kelvin. And see, the molar specific heat capacity depends on the nature of the substance and its temperature. Okay, nature and temperature. That is molar specific heat. Now, gases, if I take solids and liquids are having only one type of specific heat, whereas gases have two types of specific heat. The first one is specific heat at constant pressure, and second one is specific heat at constant volume. So let us see what is specific heat at constant pressure. If the gas takes some amount of gas and pressure should be constant. So imagine a cylinder, and in that cylinder we are fitting a gas, and there is a piston which is movable piston, and then we are heating it. So what will happen? When the temperature is increased, the pressure of the gas will also increase. So we have to keep the pressure constant. So due to this pressure of the gas, the gas will exert pressure on the piston, and I told piston is movable. So the piston will move up and the gas will expand, thereby keeping the pressure constant. So whenever pressure tries to increase, due to that the gas will expand, thereby keeping the pressure constant, and the temperature of gas will rise. That specific heat is called molar specific heat at constant pressure, Cp. Okay. Now molar specific heat at constant volume. So volume has to be kept constant. So what we have to do is keep that piston not movable, immovable. So what will happen? The temperature, we are giving the heat, the temperature will rise, the pressure will rise, but the gas cannot expand. The volume is constant. So the heat supplied is only used to rise in the temperature. That specific heat is called molar specific heat at constant volume. So which is greater, specific heat at constant pressure or specific heat at constant volume? Let us see. If the gas is heated at constant pressure, I told the piston is movable. Piston is movable. So what will happen? When the gas is heated at constant pressure, the heat supplied is used to expand and rise in temperature. So heat supplied is used for two purposes. First one, to expand. Second one, for the rise in temperature. Therefore, for a small rise in temperature, I have to give more amount of heat, because some part of the heat is used to expand, whereas some part of the heat is used to rise in temperature. But think about the second case, specific heat capacity at constant volume. Here there is no need of expanding the gas. So heat supplied is only used for the rise in temperature. So I need to give only a less amount of heat than the first case. Therefore, specific heat at constant pressure is more than specific heat at constant volume. So Cp greater than Cv. So they can ask a question, why is Cp greater than Cv? Take down that question, and the explanation, my explanation was the answer. So you can just make a note of that, Cp greater than Cv. Now see the last statement. The water has highest specific heat capacity, because of which it is used as a coolant in automobile radiators. In the car, bus and all, in the radiators we are filling water, because it is having high specific heat capacity. And water is used in hot water bags. That is also because water has high specific heat, so it can retain the heat with for a longer period of time. That is why we use water in hot bags also. So that's all about that topic. Thank you.